All right. So for my final project, I was interested in looking at some mining activity in West Africa, um, particularly this country, Guinea, which is the world's largest producer of bauxite, which is the ore that aluminum comes from. And bauxite mining requires a lot of um, land change. You have to clear a huge amount of land because it's in very low concentrations. It's not like big deposits. It's like scattered through gravel. So you have to clear a lot of land and move a lot of earth. So um, I wanted to look at bauxite mining, but I quickly realized that the available data on where bauxite mining is happening is pretty inadequate. So what I have up right now is the best data set that I could find anywhere. It's US GIS mining data, um, and it's just a few points. This is from a much larger data set that I pared down. It was showing actually mining all through Africa. I think some of the data in that um, larger data set is better than this, but this is pretty inadequate. Um, and you can kind of tell it like immediately, like there's no bauxite mining happening here. Um, there's none happening here either. Um, this is where, you know, you can tell that there is some bauxite mining, but it's still uh, really quite inadequate. So the first thing I wanted to do was look at this with better images. So I wrote a Google Earth Engine script um, to display a more recent image of the area of Guinea where bauxite mining happens. And again, it's kind of the same thing we just saw from the world imagery base map. This is what bauxite mining looks like. There's a lot going on in other parts of the region that are just not captured by that data set down here, over here. Um, and then there's also stuff going on, or there's some points that are just not, there's no bauxite mining happening around here. So, so I wanted to see if I could use tearset to um, generate some data for myself in this regard, at least just what that would look like. So I use the export tool in Google Earth Engine to download Landsat 8 images of this area. Um, I'll put the code somewhere when I turn in this assignment. Um, and then, yeah, so then I brought them up in Tearset. And so this is what a true color composite of the area around Sangareji looks like in Tearset. And there are some very obvious bauxite mining areas. Um, and I did a false color composite as well. But something I started to realize was that these images were both taken during the dry season, during which time fields are totally bare and have like exposed, very pale soil. Like up here, these are rice fields, and they're not exactly the same spectrally as bauxite areas, but they're pretty similar. So I decided I wanted to find, if possible, um, some images that would have rice fields still green. So I went back to Google Earth Engine and downloaded. I found somehow um, I found some images on Google Earth Engine that were actually from November, which is right when the rainy season ends. And as you can see in this image, the rice fields are still green. but it's still a very nice cloudless image. So that was huge. So yeah, then the first thing you need to do, what I wanted to do was use machine learning to extract all the parts of this image that are bauxite mining. So to do that, you start by digitizing training set polygons, which is what I did right here. Actually, let's add that layer to the map. So yeah, so I did it for 4 different land types. I did it for bauxite, bowal, which is like what they call exposed rock, um, bush, riparian, kind of, yeah, forest, savanna, and then urban. And urban was important to do because it is kind of similar spectrally to, um, where is it? Yeah, yeah. So it's similar spectrally to the bauxite mining area, but it's not actually the same. Like that's right here, that's a city, that's Sangreji, and then this is what the mining actually looks like. So yeah, I digitized a few of these polygons. I'll put up the bauxite too. Yeah. So we have training data. We did it for, yeah, the purple and the green areas as well. So then after that, um, yeah, so I digitized some polygons. The next step after that is creating signature files um, for each of the training sites. So that essentially is the program extracts the spectral information for all, I'm using 7 bands here, um, all of the land that I'm trying to look at. And then after that, you just feed it into the machine learning algorithm, which is called Mahalanobis soft classifier. And so you just put in the signature files for each of the land types that you are trying to analyze. And so what the result of that looks like is you get one of these images um, for each land type. So the one we're really concerned with is bauxite. And yeah, because that's the mining areas that we're concerned about. And so it's a soft classifier, so it gives a range of likelihood that each pixel falls into that category. And so we actually start to see some pretty distinct clumps of red here that do indicate mining activity, clutches of mining activity. Now, there are, unfortunately, lots of random pixels up here that are indicated as red, but it still does help us get some good idea of the extent. Then I used reclass, which basically I just created a Boolean image of the uh, pixels that had a certainty above, I think I used 80 or 85. Yeah. Oh yeah. Well, I tried both. So that's what that looks like, 80 and then 85. So obviously at higher threshold, you're gonna have fewer pixels. And it doesn't look like much until you zoom in. You're like, oh no, that actually is actually pretty useful data right there showing these areas of cleared land, basically. Then I used raster vector to convert that to a vector. And then I exported it, which is right here. You can export something into Esri formats, so into a shape file. Yeah, Esri shape file. And then I went ahead and brought it into ArcGIS Pro and put it on top of Um, so this is what it looked like when I first brought it in here. Pretty scattered, but if you zoom in again, you do have some clear clusters of where mining is happening. And it does seem to line up pretty well with that actual type of land type. But obviously it needs some cleaning up. Um, but I mean, it's actually pretty darn good. Just especially considering just how crude of a machine learning program I'm actually using. So it's not perfect. Obviously, you'd probably want more of this to be captured, but you can still tell that there's a cluster of mining activity over here. So it's some good progress. So then I just use a I use masks. Basically, I just drew polygons around these random pixels, and then use the erase tool to mask them out, because some areas that it's pretty obvious. Well, actually, yeah, look at that. So those are that's bauxite mining, but you know this stuff, these little guys are not. So yeah, use the mask or a couple different masks to kind of pare it down. It's still not perfect and it's still pretty messy, but this I could have done more over here, but this kind of does give you a pretty good sense. Obviously, that's a road. That's actually a port there. So it's not perfect, but it is a lot better than the original points that I was, that I looked up. These are the US GIS bauxite mining point data. So yeah, so compared to that, it actually seems like a pretty useful data set. And then I'm also comparing it to, I did a similar thing to extract this polygon here, which is essentially the extent of mining in 2002. This has expanded very, very rapidly. So my final project or product here compares both the publicly available data in the region to what's actually going on. And it also compares 2002 to 2022. Yeah. All right. Well, thanks for listening. And that is my presentation.